Hello, everybody. So I will today show our new approach in surface biodecontamination using VHP and our specific utility integration method for the BSL industry, really specific for the BSL industry, and you will much more understand toward the end of my presentation. But first, let's talk about VHP in general to get everybody up to speed. So what is VHP? VHP is vaporized hydrogen peroxide. So this is a combination of H2O2 and H2O. And we are using normally 35% solution, which is 35% H2O2 and 65% H2O. So this is a technology, a dry technology, a gaseous technology used on vapor form to really decontaminate all kinds of surfaces, which can be in rooms, isolators, anything which require decontamination up to a 6 log level. So some countries accept the word sterilization, some just accept the word biodecontamination because at the end of the day, it's just a surface decontamination. So only the exposed surface would be decontaminated. So since it's a vapor, it's a very, very small molecule. So it's it's smaller than 0.0003 millimeter. So this size of molecule permits to go through HEPA filters, any Tyvek, any kind of membrane easily, and is not blocked at all. So we have a very, very good penetration with this technology. And this technology has no residues. So this is the great of this technology, because at the end of the process, it will be only water, vapor, and oxygen. So as it's shown on the slide, we start from a liquid solution that we are vaporizing, keeping the vapor dry, and at the end, it is just catalyzed or just released to atmosphere to just become rapidly just water, vapor, and oxygen. This technology is used with typical cycle. So, and they are always the same, whatever the application. It can be rooms again or isolator. We will have 3 to 4 phases, where one is dehumidification. So we are verifying that we are always starting from the same humidity point. So dehumidification for smaller volume, we will really dry the volume below 20%. For rooms, 50% is okay, so long we have enough space between the dew point, the condensation point, and the relative humidity at the start, that we can put enough concentration to do the decontamination. So in terms of values, so if we have a cycle started at 20% in 20 degrees C as a room temperature, we will go for levels like 1000 ppm. And if it's just a room where we will start at 50%, we will be between 200 and 350 ppm. And we will see at the end of this presentation the dynamic of this. So this 3-4 phase, so we have a dehumidification, which is a preparation. We have also piping. So there's a lot of things done in hidden time in that phase, which is heating up the piping, heating up the machine, and then we are trying to reach as high as possible the concentration, keeping it for the time needed to get the right kill. So it will be between 3 to 6 log. And then we have the aeration, which is removing the gas, replacing with fresh air or catalyzing it. So during the whole process, really the most important is that we keep this concentration, which I will call saturation. Saturation is the combination of the H2O2 and H2O concentration below the dew point. We don't want to see any condensation. The reason behind that is Nobody can measure condensation. The condensation is not a reproducible process. When we have condensation, the liquid, any liquid is attracting the gas. So warmer surfaces will have a different kill possibility than the colder surfaces. So the idea is to really to get the most repeatable process as possible. And in terms of efficacy, the spectrum of kill of the VHP technology is the widest on the market. So we go from the easiest to kill, like enveloped viruses, up to bacterial spore, which is the most resistant, up to prions. The prions is a different industry. So the bacterial spore, really, we use the Bacillus stereothermophilus as a reference. So we will use this type of bacterial spore for our biological indicator. And considering that we kill 6 log of the most resistant bacterial spore, then we validate that we have a full coverage of any other kind of bugs. So on the market, there are 2 types of decontamination units. So we have the mobile unit. So the mobile unit are pushed inside the volumes. In general, the mobile unit can decontaminate from 2 to 500 cubic meter per unit, and this is depend much on the shape of the room. For sure, if you have multiple small room, then the gas will have some problem to reach every surface. So some fans could be added. So the mobile unit is a very manual solution, and I will explain more in detail. And we have the other technology, which is the integration. So where we place the units more in the service area, in the technical area, outside of the white room. And this technology can be distributed, as we see here, to different volume rooms, material airlock, wraps, whatever needed. And they have both their advantages. So if we compare mobile to integrated, for sure, mobile is a very easy technology to plan, because we just have to push the equipment inside the volume. Now, the cost, if it's smaller place, that's really contained. But as soon you have bigger space or complex spaces, then the number of mobile unit needs to be multiplied, and the integrated unit makes more sense. This is very easy to put in place. This is very good for people requiring just annual or biannual decontamination. Now, for sure, for the mobile unit, you need people to place the unit. The viability, depending on how you place the unit. So the unit should be always placed at the same place to guarantee we have the same decontamination as validated. If the system is a bit complex, then we need fans. We need to have additional means to make sure the gas is going everywhere. The cost, then it's the number of people. The unit, if they are placed inside an area, then they need to be stored when they are not used. And if they cannot be removed from the area, that's another constraint. And there's also cross-contamination. So if you are using people, then the biggest contamination factor for rooms, it's definitely the people, where on the integrated unit, you need no operator to push the unit. And the most important, for the maintenance operation or any callouts, any issue, if the equipment is outside, we don't need to get the people going inside the white room. So for the integrated, if you have frequent decontamination or big volume decontamination, this is the most liked solution. In terms of automation, this is fully repeatable, so we have always the same flow through the same path using the HVAC. This is much more powerful, so a mobile unit is limited by the power, the amperage of a socket. Here we can go for much higher injection rate and flow rate equipment. To make a comparison, integrated units go up to 100 grams per minute, where I think the max injection rate for a mobile unit is between 20 to 30 grams per minute. No need for extra fan. The frequent use is easy, it's just a push of a button. In terms of traceability, the systems are directly connected to the network, to the EMS and BMS directly. It's possible with the mobile, but it's a bit more difficult, and then you need also to guarantee the connections. And the most important here, the equipment is kept outside of contaminated zone. So you will not contaminate the equipment if you have to do a decontamination. This is a factor that many auditors, many people are pushing up front now. For sure, an integrated unit, then there's a bit more to do at the beginning of a project. So it has to be thought to be put inside the HVAC system. And if it's smaller volume, then the balance is going on a higher cost for the integrated. But as soon you reach frequency or larger volume, then the balance just invert. So this is the type of usual mobile unit, and this is the shape of an integrated unit, just for information. So going to the integrated solution, because today we will talk BSL, and we believe for BSL, having the equipment outside is a much more wiser approach, mobile or integrated. So we propose, we see on the market, we propose two types of integrated solution. So we have the recirculation, and this is, I worked a lot on this since 15 years actually. And this is a very, very good system, because we recirculate the gas during the decontamination. So the gas is introduced inside the ducting, is decontaminating all HEPA filter. As I said, there is no problem to pass the HEPA filters, because we are a dry technology. We are decontaminating all the surface of all the zones, and then decontaminating the exhaust filter, and then also decontaminating all the ducting, noise reducer, HVAC system, dust filter, all the coils. So the whole system is decontaminated with this recirculation. And for the pharma industry, this is definitely the best, or the most efficient technology. Now, since about 4 years, I've introduced what I call the single pass dilution technology, where for BSL, for example, we cannot have recirculation, or if we want to make recirculation, we have to create recirculation. It's going a bit against the rule of BSL. So the BSL is likely just single pass air in the volumes. The reason of that is to not recirculate any contamination. So STERIS, we thought about bringing something new to the market and to the needs of our customer, and we have decided, since we have a very powerful equipment, to just inject inside the main airstream before the HEPA filter. So we decontaminate the HEPA filter and also the police filter, the two HEPA filter on the exhaust. So that way, and this is the great of the technology, we don't stop the HVAC, where on the recirculation, we keep the HVAC on too, but then we have to recirculate. And when we recirculate, we no longer can do any pressure control. Well, that was a kind of missing on the BSL, because the BSL industry likes to have this cascade of negative pressure, where we thought, okay, let's not stop the HVAC, keep the cascade of pressure, and do the decontamination with the nominal airstream. So long the system can provide 50 to 60% RH in the supply, this was okay. And we have made a big number of a project now showing that is giving actually better result than expected. So to make some technical details, the gas is injected, both technology, recirc or single pass, the gas is injected directly inside the ducting, and this is mixed with the air. So in terms of installation, it's even less than a recirculation project. We only need to introduce the gas inside the HVAC system. Here, this is a polio application we made in the Netherlands. And we just introduced the gas inside the airstream. There is no extraction or specific extraction needed for the VHP, since we don't stop the HVAC airflow, then it's going directly to the exhaust. So the main advantages of the single pass dilution, as I said, we don't touch, we don't change the nominal airflow of the HVAC. So the airflow is kept at the same flow rate, and we don't have to stop. Many BSL applications I've seen, not just with VHP, but with formaldehyde, with other kind of technology, the people are stopping the HVAC to do the decontamination, where they lose the integrity of the pressure cascades. And the worst thing is when the HVAC is restarting, most of the time it makes a positive spike of pressure inside the room, which my point of view is pushing out any contamination in the room, so which is really not so good. So here we keep the integrity of the pressure cascade. There is no backflow possibility because the backflow topic is because you have always HEPA filters on the exhaust, and these HEPA filters are the most contaminated part of the whole application. So if there is any backflow from that, then there is a risk to really pollute, to really contaminate badly the volume. Aeration. So aeration is done with the HVAC at the same nominal airflow. We don't change anything. So we don't change the pressure. There's no special ramping required. So as I said, there are many times pressure spikes when the people restart the HVAC. So to try to avoid that, ramping is installed in the HVAC logic, but here there is no need at all because we don't stop anything. Installation, very simple. This is a single pipe. So this is just for the gas inlet for one zone or multiple zone. There is no dedicated exhaust required for the gas. So it's just one single pipe in. The distribution is as good as the HVAC permit. So in BSL industry, normally is 20 air volume change per hour. That's the normal room. I've seen with 40, 60 for special application, or if we have laughs. I've seen also 10, but normally the rule is 20. So in terms of performance, well, if you don't recirculate, then we don't have to problem with any gassing technology is we have a lot of absorption with the filters, with the noise reducer in the HVAC. So this aeration, when we do this desorption, when we do recirculation, takes some time to do the aeration. Now, if we have a single pass, then there is no more any problem for the exhaust filter to get back to the room. So it's only it's only very simple. It's simplifying a lot the process. And for the recirculation, normally we have also to stop the cooling coils, where here it's no longer needed because we need to have still the control of the humidity on during the cycle. The concentration, the concentration is likely about 300 ppm. So depending on the airflow, etc., it works normally between 150 to 200 ppm. I think the max for 22 is 350 ppm possible. And 350 ppm, so it requires something like 1 hour plus of the decontamination time for 6 hours. The consumption, well, when I put this to the market, many people think, oh, wow, this will use a lot of peroxide. Not so much, because we are more efficient. We are faster and more efficient. So yes, we need to have a strong equipment like our integrated unit, the T4 or the 1000i, 100i S6s. These are a unit which can inject 100 grams per minute or 30 grams per minute. So we need to be able to hit hard in terms of injection rate to get an instant efficacy. But because it's so efficient, then the exposure time gets less. So if we go for the average of 20 air exchanges per hour, then we need about 1.8 to 2.2 liter for 100, where on a recirculation is more around 1.5, so 1 to 1.5. So it's not so much more. And if it's a 10 air exchanges per hour, we have made 2 applications. We saw it need less than the recirculation model. So it's quite very efficient, and it's because we are instantly in concentration. And because of this, then we get a faster, we get a more efficient process, then we have a faster cycle. So, and the cycle time, so the cycle time is a total cycle. So as I said, it's about 1 hour. So it's from 45 minutes to 1.5 hours to make a rule of thumb for the exposure time. No dehumidification phase. No, we work from 50%. So that's we take what we have. We just need to heat up the inlet pipe. So depending on the pipe length between the VHP and the HVAC, that makes the time. So it can be, to make it short, can be between 5 minutes to 30 minutes in average. Aeration. So aeration depends really of what we have in the room, but if it's just stainless steel and very hard material, so that should be between 1 to 2 hours. For sure, if we have any lath wraps with active wraps or active lath or safety cabinet inside the volume, that will add some time, but not so much, so that we can stand that the typical total cycle is below 3 hours on standard BSL labs. And BSL labs are normally not that big, so that's simplified by nature. So how do we manage this technology? So we have a VHP, we have a dryer, which is creating dry air to make sure we have a repeatable process. And we can manifold the technology as much as we want. So this is another polio project. We had a very good success, and then we can manage the piping to all the labs we want. So one unit can do everything. So can do any number of rooms, zone, and material airlock from different volumes. In terms of configuration, so we can have one unit to go to different ducts for different zones. We can use the machine for material airlocks with direct connection. And this equipment will be, when we have multiple items like this, then the machine is controlled by the BMS, just to make sure that the right thing start, and there's a lot of safety on the valving, etc. But the most important is we have a very, very good data collection to the EMS. So the system is bringing a report, is bringing alarms, is bringing the audit trail, all this back to the building network for the data collection. Also, the system these days Active Directory compatible. So when you change a password in the building, it's automatically changed on the screen of the equipment. So it's really the highest level in terms of GMP. And as you can see here in practice, the machine is in its service area, connected to the BMS, and then channel to different HVAC. So here, this one, for example, is decontaminating the complete zones. Okay. And this is a 4-cycle installation. So let's say cycle 1, this is decontaminating all the zones at the same time. This will be cycle 2, which will be all the zones at the same time. But this customer here is having 2 fermentation area. So this cycle 3 will do this fermentation 1, and cycle 4 will do this fermentation 4. So this customer is using that technology to decontaminate these zones. I think there's one zone for every 3 months or 6 months. So the main zone, excuse me. But for the smaller zones, they do it every week. So every batch, they decontaminate this zone. And all this is controlled by the BMS, and all the data is fed to the network system. Okay. And that's all I have for now. So just to see in practice of this customer. So that's the equipment placed in the service area. We made a skid to place the dryer. Here is going the liquid, so the H2O2, which is automatically pumped. The system will flag when the bulk is empty or is near to the empty. We have now a traceability of the lot for the bulk. So there is a reader which is first checking the lot number of the liquid of the H2O2 will be traced inside the report, but also the system is checking the lead time, the shelf life of the product, since when the bottle is open, it has to be used in the next 6 months. So the system will automatically say, hey, the product is out of date, or you have so many days to use the product, and all this is tracked inside the reporting. And here we can see the automatic valving going to the different zones. Do we have any questions? Hello?
I think there were a number of questions on the cost, which STERIS team member Nicholas has already answered.
Okay.
Are there any further
Definitely.
questions, everyone? If not, I hand the time over back to you, Bruno. Okay, there's a question from Vachan Rasak. Is there any chance that the H2O2 absorbed by the HEPA filter cannot be removed?
No, well, the answer is a double no. The first no is the H2O2 is having let's say a short life. So the H2O2 is a very unstable chemical form. So the H2O2 will always degrade to water vapor and oxygen at some stage. That's the first no. The second no is no, so long there is airflow through the HEPA filter, the airflow will carry out the H2O2 out. So if it would be liquid, that's a different story. And if it's liquid, then it can change also the differential pressure of the HEPA filter and even damage the HEPA filter. But so long this is kept on a dry form, there is no problem for the HEPA filters.
So long as that's kept, we will have no issue with it. Any other questions? All right, I think there's a thank you from Vachan Rasak for answering the question. Any other questions, please?
Yes, I have some question, Bruno, regarding the more than the technology is the sizing of this technology. I'm concerning about the risk of the not possibility or the distribution of the peroxide into the room. There is any specific point to taking care about sizing the HVAC system, the dimension, the distance between the STERIS system and the rooms? Because I'm worried about that at some point the vapor will collapse and condensate into the tubing and it cannot reach the rooms. So
it's a very good question. So as you can see here, we have insulation on our pipework. Okay, so this is insulated, and let's put it this way: this machine at 100%, so 100 grams per minute, needs a temperature of minimum 50, I think from the top of my head is 53 inside the pipework before reaching the condensation. So we are heating up this piping during the first phase. And since the piping here used is a polypropylene with internal of fiberglass. So the piping just by design is insulated, but we put even an additional insulation on the top of it. So reaching the 50C is quite easily, but for sure, if we have long distance, for example, I have currently an application with 90 meters, and to make it safe, we have had some heat tracing, electrical heat tracing to the pipe. But put it this way, if it's not more than 50 meters, we don't see any issue at the moment. And 50 meters is quite a decent length of piping. Okay?
Okay, thank you.
Okay, so I think there's a question from Robert on what's the anticipated concentration upstream before the supply HEPA filter to achieve the 250 ppm in the room.
It's a good question. So, yes, the concentration inside this ducting will be the highest concentration of the installation. So we can be in thousands of ppm. So we can be between 3,000 to 6,000 ppm. And then as I shown before, this is diluted inside the ducting. So I take it as an example. So here we could have a few thousand ppm, but here the dilution will be instant. But yes, we can have a few thousand ppm. And as I said, that the dew point will be something like 53, 55 C inside this piper. So we need to guarantee we are not lower than this to not get any droplets of peroxide, which we don't want to happen.
Bruno, sorry again, I'll return again to my question before. I understood that the blue line that you show in this slide is STERIS VHP supplier. The green one is properly the HVAC system. So
Correct.
I'm more concerned about that line that maybe can have a not correct insulation or can bring the dew point into.
I got it.
You got it, right?
Okay.
Great.
Okay. As I said, we will make a mix not going over 300 ppm. It's because that if we take a temperature at 20 C, 22 C, the dew point of the gas mix. So the gas mix will be 50%, 50 to 60% normal air with H2O2 gas in it. So this gas mix will have a dew point if we go over 350 ppm. So long I control the system below the 300 ppm, there is no risk we get any droplet, any condensation in the ducting. Because we keep the saturation of the mix of the HVAC air with the VHP gas below the dew point.
Good,
and that's the great part of it for the BSL, because there is no liquid, it's just dry.
So that answers your questions. So next would
Does it answer your question, Simone?
Yes, you did. Yes, you did totally. Thank you. Thanks.
Perfect.
Great. Next, we have a question from Devraj. I think he has two questions. So the first is, how are the VHP recovery studies from exposed surfaces performed? How were the VHP recovery studies from exposed surfaces performed?
You mean in terms of aeration, I believe?
Yeah.
Okay, perfect. So yes, aeration is part of the cycle development work. So we want to be, if people have to come back to the volume, so we want to be below 1 ppm before we get the people back in. So what we do first, we do that during our validation process. We make sure that we put enough aeration time to guarantee that below 1 ppm. But some application, we can also put sensors. We can put H2O2 sensors, which are sniffing the volume at the end of the cycle, and which are also putting interlocks on door or interlocks on the process, that nobody can re-enter the room so long we are not below 1 ppm. The 1 ppm is kind of global rule. It's 0.5 in Switzerland, so but it's a main rule for an exposure of 8 hours for the people. So there's some limits for instant concentration for the US, but there is no real general rule. But the only general rule is for the low, and this is 1 ppm we are normally taking into consideration.
Thank you.
Great. I think Nicholas has answered a couple of questions from Devu and Sujana. So the next question will be from Fatkul Koma. How long does it take to decontaminate 120 meters cube room from setup stage to completely finish the room ready to service?
If it's a single pass system of 120 cubic meter, I would say a conservative less than 3 hours. So less than 3 hours, you can make a complete decontamination. So from the beginning till the time you can re-enter the room, roughly. If you have absorptive system like safety cabinet, things like that, depending how they are set up, can be a little bit more, but take it as a general rule, about 3 hours.
Right.
And if it's a BSL with 20 exchanges per hour, there's some. So this one is a very good installation because we have the extract placed on the lowest side of the room. But unfortunately, in many BSL lab, we see the HVAC in on the top, but also the exhaust. In the pharma industry, it's always like this. Now in BSL, it's, let's say, more than 50% on the ceiling, which is easier for the guy to manufacture the rooms. But we learn, although they have 20 air changes per hour, if you have the exhaust on the ceiling, you can have a kind of shortcut in air, which is happening for the HVAC, but also for the gas. So if it's on the ceiling, it can take a little bit more time on big volume. 120 is small, but on big volume, we've seen that if the exhaust is on the ceiling, then to reach the corners, it takes more time. So even if the people are claiming 20 volume change per hour, it's happening here, but definitely not at the corner.
Right. There's another question from the same Fatkul, but I believe that's answered by Nicholas on whether the HPV machine can be with any brand available in the market. So I think that was answered. Any other questions? If not, thank you very much to our speaker,
Thank
Bruno
you, everybody.
And we
one more question coming in.
All right, one last question.
Yeah.
So from Paul Ballerino, I assume VHP technology cannot be used if there's no airflow, for example, decon of the HEPA filters only within their containment housing in zero flow. So I think it's more of a comment. Are there any more questions?
I can comment back on this. And if it's BSL related, let me show this. It's not here, sorry. So this is BSL. So we are decontaminating the inlet and also the what many people call the police filter, so the outlet. But sometimes people want to do testing on the filter, so they may have double banks, and there's a lot of engineering on these filters these days. There are BIBO, double banks, etc. But if you have a double system, things like that, sometimes we just have one pipe going to the filter. We just only decontaminate the filter. So yes, we could decontaminate filter without any HVAC flow. But actually, that's even more common in the pharma industry. But today I wanted to speak about the BSL and the great opportunity we brought to this industry where we don't need to stop the HVAC system. But in the pharma industry, we see a lot of need, and we have a lot of projects where we just connect the gas to the filter banks. We just decontaminate the filter. The advantage of this is if you have an HVAC system shared to multiple rooms, then you don't need to decontaminate all the rooms, and you just decontaminate the filter. Now, to decontaminate the filter, again, the gassing will be quite rapid. So I would say in less than half an hour, we get the 6 log. So the gassing time is very short. It's just, it will be aerated by the VHP, because we don't want to put the contaminator back to the filter if we want to remove it, for example. Then altogether we'll make also something like 3-4 hours max decontamination time. I hope it answered the person's question.
Okay. Are there any more questions?
Yeah, sorry, Bruno, this is Paul. That was my question, all right. Sorry, just to confirm, so if the HEPA housing is isolated, how is the aeration performed if we have no exhaust from the housing?
Sorry, can you repeat? Sorry.
Sorry, yeah, so if we're performing a decontamination on the exhaust housing when it's isolated, so there's no airflow, how is the aeration occurring if there's no exhaust flow through the HEPA?
Okay, so we can exhaust to the atmosphere. We can have a catalyzer. Don't think the exhaust is really the issue. Or if you really want to contain it, then we do also mobile solution, where the people bring a mobile unit and just decontaminate the filter on a closed loop. So you don't need to have any exhaust.
Yeah, so okay, that's probably what I'm getting to. It's probably more of a mobile.
The only thing with the mobile unit, you can be limited. So if you have just one filter, that's fine. We do that very frequently. But if you have a big filter banks and things like that, that can take a while, especially for the aeration. The gassing is never the issue with a mobile unit. It's much more the aeration. So here you have this machine is pushing 200 cubic meter per hour. So if it's connected to here, we can push 200 cubic meter per hour fresh air and going to the atmosphere. That's not an issue. If you cannot bring the exhaust to the atmosphere, then the closed loop is the solution.
Okay, yeah. Okay, thank you.
We have another question from Sujana Prasad. Is there any requirement to have dedicated VHP system for AHUs catering to different suites? For example, the BSL 3 room and the BSL 2 room. Can they have the same system or different system?
That's a very good question. Frankly, I don't know any written rules on this, but I have a project at the moment where our customer asked us to separate the equipment for BSL. So they have BSL 2 and BSL 3 in the same building, and they have asked us to separate even if they put the 2 units in the same service area, they have asked us that there is no piping between the BSL 2 and the BSL 3. I think it's more the general rule to not have any potential connection between 2 and 3, where in practice and theory there shouldn't be any, but that's to make the segregation is a straight and fully secure way. But yes, I've seen that happening. Yes, where I'm not sure it's really needed personally, but that's my only point of view.
Thank you for sharing. Do we have any other questions? before we end this session, Bruno, do you have any closing remarks?
No, I'm missing Singapore. Same as Simone, I guess. And but if you have any
yeah, I agree with you, Bruno. I miss there a lot, honestly.
But if there is any last minute thoughts, etc., please come back to me. We will be always pleased to help you to understand better the VHP technology.
So we ask our members of our audience to please fill out the forms link in the chat that will enable us to facilitate better sessions in the future. If there are no further questions, thank you very much to Bruno for your sharing today.
Oh, sorry, Bruno, before you go, sorry, just a quick one. This is Paul again.
Sure.
Is this arrangement similar for IHP as well, or is that totally different?
Sorry, can you repeat?
Would this arrangement be typical for IHP technology as well? Ionized.
What?
IHP?
Oh, ionized. Okay. I haven't seen any ionized. So you cannot. So, for example, I haven't seen any ionized technology. Is definitely not my technology, but from what I've seen, is a more wetter technology. So if you put any ionized head in the ducting here in order to decontaminate the HEPA, then I'm pretty sure you will get the HEPA wet. And if you get the HEPA wet, then you may explode the HEPA filter because of the back pressure. So I think the injection in the ducting so far is only possible with dry technology.
Dry, yeah, okay. So IHP is more a mobile technology within the room itself.
IHP normally works without any flow of air, so it's more a more static. It's more a static technology, and this is also why they have to use additional fan most of the time to really push it as much as possible. And it's also kind of heavy because it's not just vapor, it's a lot of fog. And because of the gravity, etc., it's having also problem to reach higher surfaces in the room. So it's good to decontaminate the floor, but not so good for the high surfaces. Where here, STERIS, we try really to take benefit of the HVAC and get the gas everywhere. So that's why we push this approach. For sure, we have the mobile equipment. We have plenty of different solutions, but here the goal was really to reach and equally the maximum of surfaces as possible, because at the end of the day, it's only a surface decontamination technology. It's not an autoclaving. It's not something like this. So to guarantee to make sure the most surfaces are covered, we want to take the benefit of the HVAC.
Okay, thank you.
Okay, thank you very much, Bruno. Perfect timing, 5:30 on the dot. So thank you once again, and I wish everyone a good afternoon and a good evening, depending on where you are. Take care, everyone.
Okay.
Thank you so much.
Bye-bye.
Bye-bye. Bye-bye. Ciao.
Thank you. Bye.
Bye-bye.